Thanks for the patience, everybody. Dave is going to deliver our next talk, and it's going to be about TLS. So please give Dave a warm welcome.
Yes. So this is about TLS and not the other TLS. About exactly half a year ago, I think during the previous Plumbers Summit, that was around the first release of WASI sockets. And then, well, a major issue that was raised is that sockets is great, but in the real world, sockets is not good enough. I mean, basically everything that's connected over to the internet needs security somehow. For example, database connections, SQL, SMTP, MQTT, whatever, everything. And I'd say even HTTP, I mean, WASI has WASI HTTP, which is probably already secure. But it would be nice if you could provide the lower level primitives. So not every host has to implement WASI HTTP for secure HTTP connections. The whole layering stuff. What are the options? So the first one is basically for every guest to bring their own TLS implementation. One such example exists at that URL. And that works, between quotes, but doesn't have constant time operations. So they're vulnerable to side channel attacks. It won't have hardware acceleration. And if every guest ships their own TLS implementation, then it's up to the responsibility for each guest to keep up to date with all the TLS updates, cipher suites, security fixes, bringing their own set of root authorities. So there are a couple of downsides there. Another option is slightly related. It would be to use WASI crypto or an equivalent of that, which would address the side channel attacks, has the opportunity to be hardware accelerated, but it will still suffer from the fact that every guest will need to ship their own TLS implementation and own security fixes and root authority certificates. And it's also not clear if/when WASI crypto will be standardized and what the current status of it is. Option 3, and surprise, this is the one I'm going to promote, is to define a WASI TLS interface. It addresses the side channel effects. It can be hardware accelerated. It lifts a lot of responsibilities out of the guest and into the host. And I'd say it doesn't even compete with WASI crypto, similar to that it doesn't compete with WASI HTTP. It's just a different interface at a different abstraction level. So even if WASI was the gain, no, WASM was the gain, cryptography instructions, then we could still implement a WASI TLS interface on top of that. But the downside is that currently pretty much everyone depends on OpenSSL or whatever the platform of choice is. And WASI TLS would be a completely new interface to target. There are pros and cons. I've created a draft for how a WASI TLS interface could look like. At this point, it's more detailed than just an idea, but also not quite an official proposal yet. It's separate from WASI sockets, and it's separate in that it's a pure in-memory stream converter. So it takes in a set of streams, which will usually be provided by WASI sockets on one side, and it will output another set of streams, which will expose the decrypted information. A minimal example, and I've kept out a few details from here, is that basically there are two resource types for each side. So the client has two resources, namely the connection type and the handshake type, and similar for the server, which has a server connection and a server handshake. On construction of the connection, it consumes the raw TLS data streams. Those were provided by the sockets, most likely. Then you'd call connect with a server name, and you get back a client handshake resource. The handshake resource has a lot of options, which I'm not going to show here. But the most important one is finish, which just runs through the remainder of the handshake and then returns a future of the new decrypted streams. And how it looks like in pseudocode. The top part is just regular TCP stuff that has nothing to do with TLS, but we create the domain name, get an IP address, we create a new socket, we connect the socket. So far, nothing new. Then we create a new client connection, which consumes the TCP input, which were gained up here. By the way, can you see my cursor? Okay. They consume the input streams and then calls connect with the same host name and then awaits the finish of the handshake, which returns the TLS input and output streams, and that can just be used as normal. And in the very basic but very probable case, this will be it. And one thing I would like to highlight is it was just a one-liner. Let me see. Yeah, so this one is exactly the same example. Now, here is a similar example, but from the server side. It is almost exactly the same, except that we need to provide it an identity, which is a public certificate along with a private key pair. I'll get back to that later. So for the server, it's the same. You set up the server, bind, listen, accept new client, blah, 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 blah. Consume the TCP inputs. There's one additional line in this case, so it's not a one-liner anymore. We configure the server certificate and then finish the handshake, and then business as usual. Questions so far? Good. I'm going to skim over this a bit. There are a couple of details. Yep. So in the very simple example, you just call connect and directly call finish, and then the handshake is done. But some cases, of course, need some additional configuration, which can be done on the handshake object. Blah, 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 blah. The handshake object also has a way to await the server certificate mid handshake, and similarly, it can await a client certificate mid handshake for the more advanced scenarios. So this is an example of like the mid handshake receive the client identity request, which returns some request from the server if it was requested by the server. If not, then no. And on the returned certificate request object, you can respond with a specific client certificate. So all of that is within the handshake object. And then always, if you want to continue the connection, you should call finish, which consumes the handshake object. And at this point, it's just a stream. I mean, there's nothing in like 99.99% of the cases, there's nothing more to configure. So, and you can query the current status of the connection. Similar for the server. Go look at it if you want. I'm going to scroll past it. I've made an inventory of what is provided by .NET to their developers on the SSL stream types and 2 or more types, and basically how they map to the interfaces in my draft. I'm not, the main thing to take away from this is that even with a very reasonable interface size, we get a lot of green checkboxes, which is all I'm after. So that maps out what each method corresponds to in .NET versus WIT. And then I did the same thing for Node.js. Well, blah, blah, blah. Slightly less green checkboxes, but I think it's very workable for an initial draft. A couple of issues is how to obtain private keys. In the current version of the draft, the guest has to create one from basically a list of Wuyts, which contains the private key data. That will work, but it's not what you'd want. I mean, ideally, the guest should never, ever access the private key data. I don't know how. There need to be some form, just magically get me the private key, and then I don't like the guest doesn't even need to look at the bytes, but should somehow pass along it to the TLS implementation. And another issue is that in the draft, the connection resource consumes the socket streams, which is probably fine for many cases, but some tool chains or some APIs also want to be responsible for providing the TLS data to the TLS implementation themselves and not just from a WASI socket stream. So at the moment, that's not possible. One idea is to provide some kind of pipe method, which returns an input stream and output stream, and everything you write to the output stream will appear in the input stream. But that has issues. So any suggestions are welcome on that front. The problem with pipe being that if you, let me say it correctly, if you form well, basically all WASI interfaces at this moment, the host provides the data for the input stream, and then the guest can block on that. But in this case, it's a transform between guest provided data to guest provided data. So if the guest performs a blocking read on one end, and it can't possibly feed that stream. So yeah, I'd say keep it simple start out with just the bare minimum, which excludes all the mid-handshake complexity stuff, and then start including whatever we need from there on. And if everything went well, Joel is able to comment on what he has been doing on it.
Sure. Hi, everybody. Yeah, I'll put a link in here, but James and I took a minimal subset of what Dave put together as a proposal for a WIT interface, and we actually built a host implementation and a .NET guest implementation around it. Sorry, I had the link for a second and then I lost it. Hold on. We actually were able to get all the way to the point where we were able to do client HTTPS connections, to do GET requests to arbitrary websites using WASI sockets and this TLS implementation. And then also we're in fact able to use the Microsoft.data.SQL client database driver for connecting to SQL Server in .NET to connect to a SQL database and send it queries and get the responses back and everything you'd expect. So that's super exciting. What I ended up doing was forking the WASI sockets repo and just adding a new TLS.wit file. You can take a look via the submodule from the link I just pasted in to chat. But yeah, that could be where we start. You know, we've proven that it satisfies real world use cases. And then, you know, we can always add more stuff to it as necessary. So happy to answer any questions about that, or, you know, offline or whatever.
There was a question online as well, which was, does WASI TLS support the needs of both HTTP2 and HTTP3? I don't know how HTTP layers with TLS for these newer HTTP standards, hence the question.
HTTP2, I guess, yes. HTTP3, no. As far as I'm aware, HTTP3 requires some quite intricate. They need manual control over where exactly the TLS frames end, and I'm not sure. Like basically HTTP3 is like they need discrete packets of TLS frames and not a stream. So I don't think it's a particularly nice fit for streams. I'd love to be proven otherwise.
Any other questions for a speaker in room or online?
Question on the HTTP3 thing. If I'm not missing anything, it seems like we should be able to configure the TLS stream to use a specific framing for the output, and then the output is chunked into those frames.
Yes. Like the transformer operates on a WASI stream, which has no way to partition data. Just that stream.
Right, but at some point something sends that to the wire, and if you see, you presumably send it off to a socket. And if we set state on the TLS stream to say chunk this according to this schema, then we could apply that to the outgoing socket connection.
Perhaps, we'll see.
All right. Thank you very much, Dave.